Hi everyone, welcome back to Chem Help ASAP. In this video, we are going to do a little bit more of a deep dive into covalent bonds, and specifically, we are going to talk about how covalent bonds are formed. So let's get started. The formation of a covalent bond is going to be a balance between the attraction of the electrons from one atom to the protons of the other atom. Again, we get this positive, negative attraction here. However, these are not ions. We're not talking about ionic bonds. We're talking about covalent bonds. However, we have to balance that out with the repulsion of the two nuclei. So remember, in the nucleus, you have protons. That's two positive charges that are going to repel each other. When these two forces are balanced, we are going to form a bond. So what I'm going to do is I'm going to draw a graph here that is going to plot the distance between the two nuclei. So this is how close the atoms are to each other versus the potential energy that we have. When our forces of attraction and repulsion are balanced, we are going to get what is called a potential energy well, or we're going to get a minimum potential energy. So let's start drawing and see how this works. When the atoms are very far away from each other, their potential energy here is zero. So I'm just going to draw right along this zero energy line. Now, as they become closer, you get that attraction between the electrons on one atom and the protons on the other. So our energy starts to drop. They continue to get closer. The energy drops, and it reaches a minimum. Now, after that minimum, what you're going to see is you're going to see a very sharp increase in energy. Now, what we really want to do, we want to focus on what's going on at this minimum. This minimum will occur at a very specific distance between the nuclei. Now, this distance varies if you're talking about a single bond, a double bond, or a triple bond. But let's say we have taken a hydrogen atom and we have brought it close to another hydrogen atom. So out at this point, the hydrogen atoms are pretty far apart. Again, there's no attraction. They're not close enough. At the specific distance between the two nuclei, what you have done is you have formed a bond between these two hydrogen atoms. Now, the distance here just happens to be 74 picometers. That is the bond length between the two hydrogen atoms. And also this occurs at a very specific energy here, or potential energy. Now notice it is below zero, so this is a negative energy. For the hydrogen atoms, this energy is negative 436 kilojoules per mole. This is the bond energy. So this is the energy that is released when the bond is formed, or you can also think of it as the energy required to break the bond. So we have our two hydrogen atoms, we bring them closer and closer and closer, the potential energy drops, and we form our potential energy well, or our minimum. So we have formed our covalent bond, again, at a specific distance and at a specific energy. But what's going on with this other side of the graph here? Well, what you're doing is notice the distance between the nuclei. You are still decreasing that distance. So what's happening to the potential energy? It's going up and up and up. This is why we don't form bonds in here. This potential energy is higher than our minimum. We want our minimum. But at this point in your graph, what you can think about is you have these two hydrogen atoms and they are getting smashed together. The repulsion of the nuclei becomes much greater than the attraction of the electrons to the protons. What we're trying to do here is we are trying to fuse these two atoms into one. Now, is that possible? Yes, that's absolutely possible. This is what the sun does all the time. But if you think about how quickly this energy is increasing, if we wanted to do this in a laboratory, this is going to take a tremendous amount of energy. Now, the sun achieves this smashing together of the atoms, or fusion, because it is very massive. It gets a lot of help from gravity. but it still has to overcome this tremendous amount of repulsive forces to take those two hydrogen atoms and make a helium atom. For our purpose, again, we focus more on this potential energy well. What is the distance that this well occurs, and what is the energy that this well occurs? Because, of course, that gives us our bond length and our bond energy. So that is how covalent bonds are formed, plus a little side information on fusion there. I hope you found this video helpful, and thanks so much for watching.